Yes.
Sure.
Okay. Okay, hi everybody, and welcome to the live stream. We are NYU Quantum Technology Lab, and we are going to be commentating on the Nobel Prize in Physics for 2021. Do you guys see my screen here?
Yes.
Yeah.
Yes.
Okay, awesome. All right, so so on the panel today we've got Kai-Xuan Zhou, Marek Narozniak, and Manish. Say hi, everybody.
Hi. Hi, everybody.
All right, okay. So, as you can see, the stream hasn't really started yet. So, we've got maybe about 15 minutes until they start broadcasting on their side. So why don't we talk a little bit about what the expected kind of winners are. I've got a couple of pages here with Nobel Prize predictions. So, okay, so this is medicine. So physics. So actually quantum information, which is our field, I think is one of the fields which people are expected, or there's a great prospect that there might be some winners. And of these are people like Ellen Espé, John Clauser, and Anton Zeilinger. Also, in other fields of physics like metamaterials, there's John Pendry, slow light. Lene Hao, I think I'm saying that right.
British Academy of Sciences. I'd just like to inform you that we are on time.
Oh, okay.
So they will arrive 11:45.
Okay.
Thank you.
So we've got some audio from the room now, and we've got Ebube joining us, I think, and Marek's got a beer, which is excellent form.
Yeah.
Perfect one for the event.
You guys don't.
Ebube, can you hear us? I don't know. Maybe Ebube will come back to us. So, as for the possible nominations, oh yeah, there we go. Hi, Ebube.
Yeah.
Hi.
Hi. As for the possible nominations, I don't know. Any thoughts from you guys on them?
No.
No thoughts. No thoughts.
Well, personally,
Just wonderful. Thanks, guys.
I think it is difficult.
Difficult. Yeah, I'm not asking you to pick any winners, but
I mean, it is
personal preferences.
well, yeah. Say your personal preferences. What do you think?
Well, personal preferences will of course be the quantum information because everybody's working on it. But the slow light one, I've seen some research about it. I think that's also a breakthrough. There's some kind of possibility for slow light to win the Nobel Prize somehow. Yeah.
Yeah, slow light would be. I kind of consider it sort of similar kind of field because it's sort of still atoms and light. Yeah. But yeah, it's true. It's not exactly quantum information, but yeah, definitely for quantum information, it's I feel like it's really overdue. So I think in the last set of Nobel Prizes announcements for in this field, so if we look at let's look at like some of the recent Nobel Prizes
recent ones
in physics. Yeah, so last year that was black holes astrophysics, right? 2019 this is also
exoplanets.
Exoplanets, right, exactly, yes. And so 2018 was kind of laser physics, but not really quantum information as such. It was a little bit more like laser physics. And then again, 2017 was gravitational waves.
Gravitation.
Yeah. 2016 was quantum mat. 2015 neutrino oscillations. This is blue light LEDs. And so I think you have to go all the way back to 2012 for really like quantum information related things. So I feel like it's quite overdue, and I remember when this Nobel Prize came out, I think people were like, where's Zeilinger? There's no Zeilinger here at all. And people were expecting, you know, particularly like, you know, you can give 3 Nobel Prizes, and so why wouldn't you give out 3? Thoughts, Abube? Abube, you hear us?
Blue light emitting.
I think sound.
Well, okay. Anybody else?
I think most promising should
Typing in the
be
chat.
quantum information this time. But let's see. You want to say? I mean, Malik. I think, yeah, for me, I think most promising looks like that quantum information should be considered, but I don't know. I mean, quantum supremacy also recently, proposed. So, and we have time. Yeah.
No.
And we have time.
I think it's too early.
So that this is too early.
A little bit too early. At least,
Nobel
the result come
Prize in
for
physics. Yeah, goes to Google. I don't know if people like that one.
I would like it.
Yeah.
And time crystals. Time crystals. Also...
No, way too early. I think. Yeah.
Yeah.
I mean, basically, you know, Nobel Prize is a lifetime achievement award, basically, right? So, it's like there are all these old guys which are lining up to have a Nobel Prize, and so, you know, there's a backlog that needs to be kind of given out, I'd say. So, okay.
And they have to stay alive before they get the Nobel Prize.
Yeah. Yes, exactly. Yeah. So because there's no posthumous Nobel Prize, as you point out.
There are all these old guys.
I'm just looking at these. This is the live stream chat for the Nobel Prize page. So people say Ed Witten. So Ed Witten doesn't have a Nobel Prize? I guess not.
No, I guess.
Hey, Bubek, can you hear us, or can you? You're on mute. No, it doesn't. No, actually, it doesn't say that you're on mute.
Well, Ed Witten just got the Fields Medal, but not the Nobel Prize.
Ah, right. Yes, he got the Fields Medal. Exactly. Yes. What are some other people saying? General relativity. Aronoff. Yeah, that would be interesting. Justin Bieber. Yeah, some people are saying Ed Witten. Yeah, there's quite a lot of Ed Witten people. Right. So let's have a look at a few of the other pages that we have here. So here's another page that is predicting other people. So Giorgio Parisi. I know this name. Oh, I see. He's a QCD guy. I see. And Alexei Kitaev. Okay, so that would be actually a quantum information type of a prize, but I think he's too young. I mean, not that, you know, he's not done significant work, but like I said, it's sort of a lifetime achievement award, and you know, he's actually still not very old. Thoughts?
I'm checking money betting sites.
Oh.
Someone bet Nobel Prize winners.
Yeah.
But can't really find.
Yeah. Well, let me know if you find some names there. Mark Newman. What has this guy done?
That's the guy who written my computational physics book.
That I know.
Oh, you guys know him. I don't know. I don't know this guy. So he's doing. Is this like what kind of stuff does he do? Can you explain?
He written a very good computational physics book.
Okay, and so what does it cover? Things like numerical methods.
Yeah. So that's all I know about him.
Yeah, I also.
Yep. Okay. And okay, here's a CNN page. CNN always plays his videos on the top. It's quite annoying. Yeah, there's always the diversity issue that people bring up. Not enough women get it. It's only old white guys that get the prize. Yeah. So Nobel Prize is typically recognizing people who contributed discoveries 20, 30, 40 years ago, i.e. in the 80s and 90s. And yeah, there weren't many women as senior people at that time. Yeah, this is trying to say why not many women actually received the Nobel Prize. Well, so yeah, it's definitely true. Very few women are recipients. Although last year there was, I think, right?
There was.
Yeah.
Yeah, last year there was. It was joint.
Yeah. Yeah, so these front runners in the quantum information field, so these are Clauser, Aspey, and Zeilinger. So these guys are most well known for kind of the Bell inequality experiments and things like teleportation. So Clauser is, of course, the guy that's in the famous CH-SH inequality. So probably most of you would be familiar with this, but basically it's to show that there are correlations that are stronger than classical correlations in a quantum mechanical system. Well, entangled like a Bell state, you can show this was basically Bell's achievement, but this was better quantified in this CH-SH inequality that you can violate kind of the maximum bound or maximum correlations that you can have if it's a quantum mechanical particle. So this is the so-called CH-SH inequality, and Bell had his own version of the inequality, but then Clauser and people they managed to refine it further. Yeah, so I think Clauser was also a
Signing.
yeah. So I think he also tried to do an experiment. Do you guys remember? So Dowling was talking about how Aspey took over somebody's experiment. Do you guys remember this story that Dowling used to tell? Something to do, I think it was Aspey's.
No.
No, cannot remember. It was something like I might be wrong if it's Aspey, but there was some experiment that he inherited all the experimental apparatus from, and basically they bought it off some university. But
Yeah.
I can't quite remember who that was. So it might have been Aspey or Clauser. So yeah, so Aspey was the first guy to do a proper Bell inequality measurement. and of course since then he has, the first generation of experiments, like, the entangled pairs were very close together, so there were all kinds of loopholes that needed to be kind of filled in. But since then, you basically have to, people filled in all the different loopholes, like locality loophole, and so I think more recently they basically did an experiment. Maybe it was even Zeilinger. So Zeilinger did a whole generation of experiments where they could fill in all these different loopholes. But Aspect is, I think, credited for doing it first, and I think Clauser also was trying to do an experiment, but maybe it didn't quite succeed, or I'm not quite sure on the details there. But he certainly was, one of the main guys in the theory of it, so the CHSH inequality.
I think they propose multipartite entangled states.
CHSH?
Yeah, I think.
Right, yeah. So, I mean, later on they generalized it.
Good morning.
High-dimensional systems.
Welcome to the Royal Swedish Academy of Sciences and this press conference about the Nobel Prize in Physics. It's good to see all of you here today. And I would also like to welcome all those who are watching this press conference over the internet or on TV. I'm Göran Hansen. I'm the Secretary General of the Academy. And with me today, I have two members of the Nobel Committee for Physics. On my right, Hans Hansson, who is the chairman of the committee. And on my left, Professor John Wetlaufer, who is also a member of the committee. The Academy met in session this morning. We have taken the decision on the Nobel Prize in Physics. We have contacted the laureates. And now we're here to tell you about it. I will read the announcement first in Swedish and then in other languages. Professor Hansson will make some remarks on behalf of the Nobel Committee, and Professor Wetlaufer will present to you the science behind the prize. Kungliga Vetenskapsakademin har idag beslutat att utdela 2021 års Nobelpris i fysik för banbrytande bidrag till vår förståelse av komplexa fysikaliska system. Den ena hälften av priset utdelas gemensamt till Shukuro Manabe och Klaus Hasselmann för fysikalisk modellering av jordens klimat, kvantitativ analys av variationer och tillförlitlig förutsägelse av global uppvärmning.
Climate.
Okay, well that is left field. Okay.
Till Giorgio Parisi för upptäckten av hur oordning och fluktuationer samverkar i fysikaliska system från atomära till planetära skalor.
Parisi, this was one of the predictions, yes?
The Royal Swedish Academy of Sciences has today decided to award the 2021 Nobel Prize in Physics for groundbreaking contributions to our understanding of complex physical systems.
All right.
One half of the prize is awarded jointly to Shukuro Manabe and Klaus Hasselmann for the physical modeling of Earth's climate, quantifying variability and reliably predicting global warming. The other half goes to Giorgio Parisi for the discovery of the interplay of disorder and fluctuations in physical systems from atomic to planetary scales. Die Königliche Schwedische Akademie der Wissenschaften hat heute beschlossen, den Nobelpreis für Physik des Jahres 2021 zu verleihen. Eine Hälfte geht gemeinsam an Shukuro Manabe und Klaus Hasselmann für das physikalische Modellieren des Klimas der Erde, die quantitative Analyse von Variationen und die zuverlässige Vorhersage der Erderwärmung. Die andere Hälfte geht an Giorgio Parisi für die Entdeckung, wie das Zusammenspiel von Unordnung und Fluktuationen physikalische Systeme von der atomaren bis hin zur planetarischen Ebene bestimmt. l'Académie royale des sciences de Suède a décidé ce jour d'attribuer le prix Nobel de physique 2021 avec une moitié conjointement à Shukuro Manabe et Klaus Hasselmann pour la modélisation physique du climat de la Terre, l'analyse quantitative des variations et la prédiction fiable du réchauffement climatique. Et l'autre moitié à Giorgio Parisi pour la découverte de comment le désordre et les fluctuations interagissent dans le système physique d'échelle atomique à planétaire. Korolievskaja Akademija nauk rešila Zevonia Prisudić Nobelevsku premiju po fizike одну половину pornu Shukuro Manabe и Klaus Hasselmann за физическое моделирование климата Земли, количественный анализ вариаций и надежный прогноз глобального. А вторую половину Giorgio Parisi за открытие того, как беспорядок и флуктуации
I thought this Giorgio Parisi was a QCD guy. So this is not wrong, but he's doing more like complex systems, so statistical mechanics type thing, which
Here are some brief
kind of
biodata.
related to
Shukuro
QCD.
Manabe
Alright,
was
he's a
born in 1931
bio.
in Shingu in Japan. He got his PhD from the University of Tokyo, and he is, since many years, senior meteorologist at Princeton University in the United States. Klaus Hasselmann was born in Hamburg in Germany, also in 1931. He got his PhD from the Georg August Universität in Göttingen, and he's now at the Max Planck Institute for Meteorology in Hamburg. Giorgio Parisi was born in 1948 in Rome, in Italy. He got his PhD at La Sapienza Università di Roma in 1970, and he remains at La Sapienza as professor. With that, I'd like to ask Tors Hans Hansson to make some remarks on behalf of the Nobel Committee. Hans, please.
Thank you. So, many of you might believe that physics is only about simple and ordered phenomena. I'd like to ask
Tors Hans Hansson to make some remarks on behalf of the Nobel Committee. Thank you.
Alright, well, I think they're going to go through and do a whole bunch of speeches from here, which I think you can always watch offline. So, alright, what's your reaction? Yeah,
No quantum
yes, no
information.
quantum information again. Yes, it's a tragedy.
So,
It's a disaster. Yeah.
long way to go.
Oh, I'm gonna close all these windows with quantum information in it. So, yeah. Anyway.
Well.
What? You sound like you're very happy about it.
You mean me?
Yeah.
Not really.
No, not
When
really.
you said that, yeah, when you said that it's a disaster, I'm just laughing because that's what Nobel Prize is always about. It's full of surprises. You never know where they're going to. Yeah, you never know where they're going to. What they're going to get out of their way.
Yes.
So, and when you are saying that it's mostly old people, I keep on imagining the BEC Nobel Prize went to very young people at very young age.
It's true. Yeah. Yes. Well.
So I don't know.
It's
but
true. Yeah. So it can happen. But I mean, okay. Look at the ages of these guys. This guy's 90. This guy is 73. This guy is 89. So.
Yeah.
No, I'm not saying mostly they're old men or old people. In general, they are very old. But I would still say I wouldn't say it's a lie. Well, I don't know, but whatever that may be, I would say it depends on how hot or how soon you're able to jump into the modern trend of a thing and able to make it. Yeah. Then coming to what you guys were saying earlier about Zoninja and aspect, I think, and an aspect.
Yes.
I don't know.
Yeah.
I think those guys. I don't know whether. Well, if they are giving something on quantum information, will it actually be those guys? I think it might equally skip them. I think
totally
if you're talking about, I think if you're talking about something like, doing something like laser things or laser kind of atom light interaction or manipulation, something like that, maybe you might think of them. So I don't know, in terms of quantum information, I don't know where to categorize them. And these Nobel Prize people, I think they do it in cycles. I think they do it in cycles. So I don't really know.
Yeah. Well,
even next year, I'm not so sure that it will come back to our field, they say.
Yes, I mean, gravitational waves was one of those sort of big ones that, you were sure that they were going to get a Nobel Prize, right? I mean, in that case, they happened to be kind of also old guys, but I mean, that was pretty soon after the announcement. So, I agree with you. There's some big results that everybody's pretty impressed by, and then you just, you just got to give it to them.
Dark energy.
Well, I guess climate is, still a hot kind of topic, right? So, it's environmentally connected.
Yeah. I think many countries or nations are talking about doing something to curtail the green gas emission or greenhouse emission or something like that. So climate is really a hot one, and for them to be able to come up with models, I think that's equally impressive because it's ever dynamic thing.
Yes. Yeah. So you can see that they're talking about greenhouse kind of stuff here. So. Yes. Well, I don't know. Well, poor Zeilinger, he may not get the prize if it's going like this.
Maybe not this year, next year we can.
No, I would love him to get the prize. But I don't know.
No.
Yeah, I remember you at some conference just going, just give the guy a prize. I mean, go on, just it's just a medal, just give it to him.
Yeah.
Okay.
If you double the carbon dioxide,
Well, but I can see in the chat here. This is the Nobel Prize page chat. But there's people that are saying, Aspe and Peter Shaw as well. So that would be quite weird if Peter Shaw got a Nobel Prize, because he's not really even a physicist.
Well, I think maybe for quantum information, to be honest, for quantum information people, I think they may start thinking of getting a Nobel Prize, if I'm correct, if they start demonstrating, the benefits or the fruits of quantum information in large scale, not necessarily in small scale, maybe for military applications and hidden uses we don't really know. I mean, for large scale, when population starts to benefit, I think maybe that's when they might say, okay, it is really mature. Let's look at people who really made this to happen. That's what I think. But for now, I think everything is hidden, and people are wondering. Like, I think even in the United States, people are now starting to think. I think they launched Quantum Information Initiative in 2018, I think. But by now, people are already looking because they want to reach. I think they gave them 5 years, 1.2 billion, to see what they can come up with in 5 years. And people are now, people are like tinkering their head and scratching their head. If these people don't really show us anything meaningful, maybe we better scrap this, or it's a hype or something like that. So we have to really tread careful. That's why I'm saying I don't know what the Nobel is thinking or how other people outside quantum information are seeing this, because I believe these other people will also make a contribution into whether the area is going to really get something. So I don't know.
I think it is growing field, not.
Yeah.
Who is giving this lecture?
Some guy.
The committee members.
You know, it's usually somebody, some Swedish professor. I think that's the normal protocol.
Okay.
Yeah.
Because we see them
Liquid
in
to
glass.
glass.
Glass is fractured like a solid. Yeah.
Oh well.
Flow.
Okay. Well, well, this will go on for a while. So maybe I think we can just wrap it up there.
Yeah, I'm up for being. See you guys tomorrow, right?
Yeah.
Okay.
Yeah.
Yeah, awesome.
Okay. All right. Well.
All right. See you guys.
Yep. See you and well, next time, next live streams. Perhaps next year.
Okay.
All right. Okay. Goodbye, everybody.
Goodbye.
Study a main version.